Welcome everyone. Today we will be presenting our project, Medical Passport Web Application. Our team, Team Pegasus, Team 61, consists of Jeffrey Liang, Rachel Powers, Randall Sewell, and Zubaria Shahab. For the agenda, we have the introduction, discussion and research retrospective, demonstration, and future work for our presentation. We'd like to introduce our team. I'm Zubaria Shahab, and I'm responsible for the database administration. Jeffrey Liang and Rachel Powers are our backend and front-end developers who have worked on the UI and the backend. Randall Smith handles database administration, and together we have developed this innovative solution. The Health Passport web application aims to provide users with a digital platform to store and manage their medical records. This includes information such as vaccinations, medications, and health issues. By using FHIR standards, we ensure seamless data exchange between different healthcare systems and also ensure a quick and reliable access to personal medical records. In today's world, quick and reliable access to personal medical records is essential, especially in emergencies or while traveling. However, one of the significant challenges in healthcare is the fragmentation of medical records, which are often stored in different systems across various providers. This lack of integration complicates the sharing of health data, leading to inefficiencies, repeated tests, and delays in care. These issues are amplified when patients travel internationally, as they may struggle to verify their health status, such as vaccinations, to healthcare providers in different countries. Healthcare providers often struggle to make informed decisions promptly because they lack access to comprehensive patient records. To address these issues, our project aims to create a unified platform for health records, ensuring seamless interoperability and giving patients control over their data. Our app will make health data accessible anytime and anywhere, improving healthcare delivery.
To secure our application, we implemented OAuth 2 authentication using Auth0 after exploring different providers. Auth0 provided a streamlined tenant management system so we could implement secure user authentication and protect sensitive healthcare data. Configuring Auth0 required integrating its services with Spring Security in our backend to validate JSON web tokens that are issued during authentication. The implementation wasn't without challenges. Ensuring compatibility between Auth0 and our front-end back-end communication required debugging token handling, authorization workflows, and setting up robust routing. However, by conducting detailed research on OAuth 2 flows and Auth0's documentation, we successfully delivered a secure and robust authenticated login system. Our UI was designed with both aesthetics and accessibility in mind. We selected a clean color scheme of white, light blue, dark blue, and mint green. Research from the healthcare domain suggests that blue tones evoke trust and security. Dark blue was used for headers and key informational sections, and together, light blue and white provided a clean, uncluttered background. Green tones symbolize health and vitality. We used mint green to draw attention to actionable buttons within the app. For the health summary section, we carefully selected cards to display the most relevant patient information. These included allergies, immunizations, encounters, and medications, according to the common resources in FHIR. After initially experimenting with Cynthia, we utilized the Smart Health IT sandbox at launch.smarthealthit.org to generate realistic test data, such as patient encounter and observation resources. This resource allowed us to simulate real-world scenarios while ensuring compliance with the FHIR R4 standard. One of our team members, Rachel, played a key role in this process by developing Postgres tables and Java DTOs to map FHIR resources into our backend. These DTOs meticulously aligned with the FHIR specification, enabling us to transform JSON responses from the Smart Sandbox into objects that fit seamlessly into our Postgres database. This approach allowed us to store, retrieve, and process data in a structured and scalable way.
For the demonstration portion of this presentation, please play the inserted videos on each slide. To deploy locally, you'll need to clone our GitHub repository. Once this is cloned, you'll need to navigate to the project's main directory. And from here, you'll be able to build the back end and also build the front end using these Docker build commands. Once this is done, we are able to run the Docker compose command, and we are able to create our containers. We'll have our Postgres database, our front end, and our back end deployed. To log into our application, please navigate to localhost 3000. After you click the sign in button, you'll be rerouted to Auth's sign in page. You can see in the network tab that our backend routed us to this authorization page. From here, enter in the email address that we've provided. These are users' profiles that we've already created. I'll go ahead and put in the username and password. And now you can see we have been navigated to the user's health summary page. To demonstrate the onboarding functionality, we'll need to go ahead and create a new user. So we'll go ahead and select sign up and enter in a dummy email address and password. Once we've authorized this application, we'll go ahead and be navigated to the onboarding page. For this example, I'm going to be using information of a patient that I know exists within the FHIR server. So I'll enter in their first name, their last name, and date of birth. We can also enter in the Social Security number, but this is optional. So when we hit the finish button, what has happened is we've made an API call to our backend that queries the FHIR server for patient record. That patient record comes back, and then we get information including the medication procedures, encounters, etc. And we internally turn that into our user profile DTO. So in this case, we did get information sent back, and now we need to verify that information. So we prompted to confirm the address and to confirm any medications. If the user were to select no at any point, you would have to enter in the data manually. For this example, I'll go ahead and press confirm and import the user data. You can see here now that the user data has been transformed for what was inside of the FHIR server into our own DTO, and now we are seeing this information displayed on Barney's medical passport page. To demonstrate our manual input option for onboarding, I'll go ahead and input data into the first, last name, date of birth, and social security number that I know does not exist within the FHIR server database. So when we query this to our backend, we won't get any results. So we're prompted in saying that there's no records found, so we'll need to manually input this data. Some of the data that I've already selected is pre-populated, so I'll go ahead and enter in some information. I'll add my email address. I'll go ahead and select my blood type and enter in more personal information. And then from here, I can go ahead and add in medication that I am currently taking. So I can go ahead and enter in some dummy data. I'll go ahead and select the start date. End date is required, so I'll just leave that blank. I can also go ahead and input some data for allergies. And you can do this for each section in which we have. If I were to go ahead and enter in or add an allergy that was a required field, I'd be prompted to input this data. So I'll go ahead and add an allergy. We're able to do this for each section. I'll just go ahead and pass this for now. And then we have summary information. So I'll get to verify everything that I've inputted. And if it looks good, I'll go ahead and submit. Once I submit, you can see that I have now created my own medical passport via manual input. To demonstrate the editing functionality on the medical passport page, we can go ahead and enter in a new allergy. So you would click on this Edit Allergies icon, and I'd be able to enter in the name of the allergy, reaction, select severity, and then also the time in which this became viable. Let's go ahead and click Save. And now you can see our Allergies tab has been updated with a new record inserted. We can also update a medical user's information. So here, let's say that John has a new last name. I'm able to go ahead and select a new last name. We can also edit their phone number and even their blood type in case they inputted some information wrong. We'll go ahead and save. So we can see the last name has changed and we've added a new allergy. The UI has updated. If I go ahead and log out, we can sign back in with the same email and password for John. And now we can see in our database it has persisted. We have added in a new allergy and updated his name, phone number, and blood type. Another feature our application supports is generating a PDF from your medical passport data. You can go ahead and select the Generate PDF button, which will then prompt you to save this PDF into your file system. I'll go ahead and click Save. And then once this has been downloaded, I can go ahead and open this up. Now you can see that we have a PDF of our medical data that we can bring along with us to another healthcare provider that may not be in the current FHIR server system that contains this information.
Hello, this is Randall, and I will be presenting the Future Work section of our presentation. One of our future updates would be the implementation of an account setting page. This would be a page where users can do basic user options, including changing their username, updating their password with built-in validation to ensure the password meets requirements, and set up other security measures like two-factor authentication, and also allowing options like deleting their account, including options for data export and to ensure compliance with applicable regulations. Another update in the future would include enhanced saving and export options. This would improve functionality for PDFs, including the ability to save patient information directly as PDFs. It would allow users to save data to their account for quick access and backup, and also to specify which information they want to include in save files, providing options for flexibility and customization. Another update would be to improve the FHIR information retrieval. Currently, when a user first retrieves information from the FHIR server, it's a single retrieval and essentially static information after that. Future updates would develop options for periodic synchronization of FHIR data, possibly even real-time updates pushed from the server as it changes, and ensuring that the patient information is always up to date. We could allow users to customize synchronization or possibly enable the previously mentioned automatic update from the server. This would address the limitation where the system only pulls data once per user. An additional future improvement would be mobile platform development. Currently, our system runs as a web app, and we could expand this into a mobile platform, including both iOS and Android applications. This would involve designing responsive and intuitive UIs tailored for mobile devices, and we would be required to ensure cross-platform data synchronization and integration with the existing web system.